kicking off the breakout sessions with our first speaker, Len Bosack, who will be presenting XKL 400 gig during the pandemic. Okay, Len, I promise I did not write this. Len co-founded a small networking company called Cisco Systems. He made rapid progress in network speed and protocols. His current work at XKL is making the equipment for fast and reliable optical networks that are easy to deploy and operate. Len?
Thank you, Alex. Well, yeah, it is true. I did indeed co-found a small networking company. It was small when we founded it. But what that also means is I have been through pretty much every next big thing there has been in computer networking. I was involved with several of the very first Ethernet interfaces. It ran a little less than 3 megabits per second. Rather more 10 megabit interfaces, then 100 megabit, although that was first fiber rings, and then a gigabit, and 10 gigabit, and 100 gigabit. And so far, I haven't seen any commercial reason to build a 400 gigabit Ethernet interface. But I can tell you, each time we increased the network speed by a factor of 10 in a step, it did matter. You could do things at the higher speed that you couldn't do with the lower speeds. Same thing with switching capacity. You know, you get to 10 or 15,000 packets a second, then 140, then a million, and then a few million. And by that point, I'd outrun the network industry. Fortunately, they decided to pay attention and got it to go faster yet. Anyway, what I'm trying to say is so many technologies come to us with bright, bright promises and shiny marketing materials, don't forget that. But they don't, certainly at first, present as wonderful things. Still, in time, they improve and they become useful tools at the foundation of what people regard as their daily lives. So, this brief talk describes, this talk will come in two parts. First, there's what was it like to do a development project during the COVID pandemic? Well, the good news is we got it done. The bad news is it was a little strained at times and a bit of a bumpy ride, but various of you have all lived through that, so I'm not going to dwell upon this part. Certainly substantial changes were needed in operations while COVID was, or at least the administrative lockdowns were in full stride. We turned out to be inadvertently very well prepared. Our main engineering and test lab has a row of racks down the middle with over 100 of our systems in there and a bunch of benches around the edge. So we had made it possible for most engineers to set things up, and unless you actually needed to run a probe around something, you could set things up and then nicely go back to your desk, VNC into whatever it was you needed to deal with, and continue. Well, what's the difference if you're doing the VNC from home? Mostly the network was good enough for this, and so we could continue our even low-level hardware development activities. Particularly, we had one gentleman who actually did gateware development from his house across the Puget Sound. Not so bad. And you know, in time, you've all heard about the well-known supply chain problems. I'll talk about them just a very little bit. All right, let's get ourselves along, shall we? There we go. Okay, this is a mandatory slide, I'm told. It'll show you what I'm going to tell you, which is it comes in 4 short slides. I said I wasn't going to dwell on this, but hopefully it will give you just an idea of how things went. Okay, this very busy slide covers 4 years of development. And these are some of the current products, one of which is announced today, which is a 12-port 400 gig wave, 12 wave 400 gig product in a 1U package. Okay, the upper section, all that reddish stuff, shows you various events and some data. That curve in the background is the curves of people who died of COVID in the United States. However sad that may be, it's true. A little bit of a factoid for you. Our factory and offices are in Redmond, Washington, about 5 or 6 kilometers from the first COVID hospitalizations of any scale. That caused a certain pause in people's way of regarding the world and how safe it was to go out. So we had to deal with all of that. Something about fear, uncertainty, and doubt in being up close and personal. Well, there you had it. Now, more details on the following slides, but one thing I'd like to point out is the substantial difference in time between how long it took us to build the 12-port system. It's going to be too hard to read on this slide, so we'll go to when we see the detail slide, I'll point it out there. But basically, the 12-port system was the first one we designed and built that in 3 weeks. A 4-port version, because we figured out that people probably couldn't use 12 400 gig waves all at once, or not too many could. That took 4 months. Okay, then. All right. This is the initial detail where you'll see that story starts with OFC in 2019. We had a number of good backroom conversations with our vendors. We were reasonably convinced by then that we were going to see something like 400ZR in about a year. Okay, so we started the projects. In our section of the marketplace, people truly prefer 1U products. And this was going to be a bit of a challenge to get, so initially the exploration was, all right, how many can we put in a 1U chassis? Well, the answer was 12. We could cool it, we could interface to it, and so we went about detailed design, and a year later, less than a year later actually, the designs were sent out to fab. 3 weeks later, we managed to get the boards back, had initial systems, testing started. You start with electrical and thermal tests with dummy loads and things of that sort. There's a wonderful Lebanese company that makes a factoid for you, a device that you could program its power dissipation, and that turned out to be quite useful. And we were looking forward to something ZR in the summer. Okay, as the designs progressed, we had found there were some parts that looked like they were going to be hard to get. And so we actually started placing orders for them. This was well before the supply chain collapse. And that left us, better to be lucky than good, quite honestly. We did it because we thought that this might be a problem in the future. We were right, and it was quite beneficial. Now, we count the supply chain collapse from the first time that we got a serious 52-week lead time quote. Honest to God, you send them a PO and they said, 52 weeks. Okay, that's a little hard to deal with, actually. So we figured, all right, this 12 at a time might not be such a good strategy. So we also decided to build a 4-port variant of the system, started the design in there, and eventually that was fabbed, and here we were going along. A number of vendors told us that we were quite literally the first people outside of their laboratories who could tell them whether a 400ZR device actually worked. We had 400 gig sources. We have an enormous raft of optical instrumentation. We have a fiber test bed with 2,000 kilometers of fiber in it. We have test sources in more than 100 of our existing systems. So we're well positioned to do that. And, well, the very first thing we got in the middle of the summer was actually a laboratory prototype from one of our vendors. And of course, they can't really sell you that. You don't expect it to work. Nobody does. It's a laboratory prototype. Okay, but we took it, we looked at it, and we could indeed find things that worked and things that didn't work. Both companies' programs really benefited from this. And we were hoping for alphas later in the year, which did eventually come about. And really, that lab prototype exchange was a real winner. Both companies learned quite a bit. And I think it progressed both programs probably a good 3 months faster than they might have been. Well, supply chain problems were really starting to slow the whole industry. Our first beta ZR arrived in late May 2021. And here we were ready considerably in advance of that. But at least we could start what you could sensibly call system tests. All right, you get finally into 2022. And, well, another year had gone by. So it was 20 we thought we could get the optics. 21 is when we really got them. 22 is when you started to see the factory produce optics. And we waited until we actually had a firm ship date for our moderate quantity orders before we announced any 400 gig product. I know there were lots of people out there beating the drums, but when we announce something, we actually want you to be able to get it, like in less than half a year, perhaps. We're among the few people who now can ship 400 gig with a acceptable, well, couple month lead time. All right. So Nanog 86 was the announcement. Lead times have improved enough at moderate quantity that we're willing to announce the 12-port system, which was the first one that we built. So here it is, currently announced at this Nanog is our 12-port system. And, you know, progress is being made. I suppose the next part of this talk is going to be, this was the story of how we got anything at all through COVID. And, you know, there's a lot of details in these slides, and I didn't want to bore you with all of those. At any rate, let's move on to the next part, which are the specific experiences with the ZR. And when I say ZR, I mean ZR, ZR Plus. There's some struggles about how to make ZR Plus. There's a lot of, it's more a software issue than anything else. And as you'll see, the industry has a little bit of a struggle with that. Okay. So this section of the talk tells you about what we actually experienced. And remember, we started out with people's laboratory prototypes. You don't judge a product by a laboratory prototype. That was something that you were testing, and you know, we all fix our products and make them work well. So did our vendors. If you manage to order and get one of these wonder modules, and you go and push it into a system, what should you expect? Well, there's good news and there's bad news, and let's talk about some of the news. Well, your basic 400 gig client to client, if you have a 400 gig port at one place and a 400 gig port at another place, and the optical path is straightforward, you can probably get that to work. Many choices of client optics will not entirely get in your way. Some will. So client optics are still problematic. Sorry, that's just, you know, how it is just today. Now, we have gotten very good and flexible results using DR4s and DR1s, for example. We have, some of our customers are predominantly 100 gig. So they really like the ability to run 400 more or less independent 100 gigs down a 400 gig wave. And that's easily feasible, at least as we've programmed things. If you want to go to suddenly, you want to change, you suddenly get a 400 gig switch port that you need to use, pop out the MPO connector that had the breakout for your LCs and run your little ribbon over to your switch and type a command or two to our software, and you got 400 gig. That's pretty appealing in terms of being future-proof. Okay, the bad news. If you've been in the optics business very long, you know that when an optical component gets to manufacturing release, it has been through a torture test of shake, bake, zap. It's literally been tortured to see how long it'll run. Well, now, what you see is that it's not perfect. Okay, well, and we're going to talk about why. These systems, these little plug-in components, now contain not only a truly significant digital signal processor, and actually some pretty miraculous optics. They've been miniaturized far beyond what anyone 10 years ago would have thought was going to be commercially feasible. So there's a lot to credit here. There are a lot of good things to say. But so not only are they complex optical systems, they are now also complex computer systems. And our friends in the optics industry, they're not computer people. They're just not. So the optics and the supporting DSP, everyone knows they're essential. They spent a lot of work on that, and they're working pretty well overall. The computer systems came later, and I'm afraid the answer is not so much. So never has anyone tried to put that kind of computer in any sort of miniaturized optics. And they're struggling, and I'll talk a little more about that. Strangely enough, this is going to shock most of you here, the software and the firmware interact in ways that are sometimes unexpected. Couldn't have seen that one coming, now could you? All right, well, it's happened, and it's happening. There is also a tremendous amount of data to manage internally and to report. There is a lot of stuff going on here. There is a lot of complexity, some of which is useful to know. Well, that's been problematic. There have been a couple generations of the so-called CMIS standard, something about common management. Common? Oh, oops. Not every vendor did it the same as every other vendor. So when you get a number from vendor A, you really need to know whether vendor B's number is even similar, because sometimes they're not. A little bit of actual algorithmic complexity in places, particularly involving very longer spans with dispersion compensation, but mostly they're over that. But the user visible effect of all of this is there can be what seem to be hard edges. You can't reason because something has worked for you, whether you do something that to you seems just ever so slightly different. It may just not work at all, because there's something about what you changed that for you was inessential, but for these particular products was a real problem. So there are some surprises here. In other words, just as we go through an enormous number of test cells and test iterations, if you're going to go and do something in production and you're going to just pop things in routers, you really need to try it in a, how do you say, safe environment first. Okay, there are other things about it. All this wonderful miniaturization, Well, even at 7 nanometers, this stuff dissipates a lot of power. You know, it's something on the order of 17 to 20, or if you're really turning all the knobs to the right, you can get them up to 22 watts in a compact module. And for any given device, and it varies from device to device, which parameters that you change changes the power in somewhat different ways. Okay, so here you go. Strangely enough, if you dissipate that much power, its temperature tolerance in terms of just how ambient cooling air works is going to change. Nobody knows what the real lifetime of these systems is going to be. In the past, we had fairly simple optical, and you know, the principal life-limiting component was a laser, and we knew what that physics was. With these systems, we're just really we're guessing. Not only that, but when you put them into devices that were not designed to cool this level of power, take this level of power out, do watch the power limits and the power density. Putting 4 of these in a row may not be your brightest idea. Now, another thing that's going to seem a little odd is some of the multi-system agreements, the MSAs, give them 6 minutes to start up. Yeah, you turn your box on, and then 6 minutes later, your optical fiber is ready to take data. Now, we've never seen anything like that bad, but we do see, depending on how you're configuring things, times in the order of a minute. So this is, for some people, potentially concerning. Again, no criticism intended. These devices put out a factor of 10 less power than your typical 10 gig device did. They just couldn't get everything into this package and not melt it. So there's no additional amplification at the end of it, and you get minus 10 dBm out. Now, some people have ideas about being able to build micro EDFAs in, careful about what you're going to put downstream of them, because there's a tremendous amount of broadband noise coming out now. I don't really want to dive into the optical physics, because that's not what you're here for. This is about building networks, not about the squeaks and beaks of optical fiber. But you have to know one other thing. If you want to go a long distance, for example, if you're going to go alien wave, there are a fair number of existing systems that will not readily pass 400 gig. And that's just true, because this is a wider bandwidth, complex, dual polarization modulated signal. And bits of what's called polarization dependent loss and things of that sort that you can skate, you won't even see at 10 gig, and you can usually skate by at 100 gig. It may not work here, so caution's there. And even stranger, the inputs that so for example, everybody goes and unplugs fiber. You know, that's just sort of, when you're setting something up, that's just what you do. These modules can take a surprisingly long time to recover from that. Again, tens of seconds. It's for a fiber plant that's stable, nothing's going wrong, you may never notice it. But then when things do go wrong, you might. And that's just one of these unexpected things. And that is primarily software driven, and my hope is can be improved. All right, well, that doesn't sound like the next big thing, now does it? Well, first off, I mean, the first disappointment is, it's 400 gig, not a terabit. So that doesn't meet my earlier criteria for what's it take to make a real change in the world. But still, it's a nice improvement, isn't it? 400 gig anyway. So why are we bothering? Well, look, there's real benefits here. On a per gigabit per second, power, cost, and space are better. Now, just right now, and it's still early days with getting their internal software to finally stop wiggling in front of them, but this will eventually stabilize and be more conventionally reliable. Also, if you're doing this because you want to transport 100 gig, okay then, eventually you're going to get 400 gig switcher router ports and change the, pull the MPO out, change your fiber plant a little bit, type a command or two, and you're running a 400 gig now. A lot of people find that prospect appealing because depending on where you are, I mean, if you're Microsoft, 400 gig is very popular. If you're Google, probably. I mean, I know for Microsoft for sure they'd end the street. If it's Google, I'm not so sure. I assume so. But for the rest of the world, not every router has 400 gig ports on it. Not every switch has 400 gig ports on it. There is a lot of 100 gig in the world. And this trick of running 4 100s down a single 400, I think is a very good transition and bridge. And you're ready for your higher port speeds. Okay, I think we're just about to the point where I promised to be ready to take questions and answers. That was a 30-minute version of what should have been a 26-minute presentation. And so if you have particular things you'd like to see more of, obviously we went through a lot of things. And if anyone would like more detail or you have particular questions, this is your time. Or even if you just want to ask a question. I've been in this business a long time. I might remember. My goodness, it's Alex. Wrong button. Not quite. Help is on the way.
Turned off? Wait for the feedback loop to settle.
Yeah, don't hit that one too hard.
Okay, DSP is a wonderful thing. Alex Latsko, speaking for myself, not Nanog on this one. Question being, for the early release ZRs, where the firmware is janky.
That's polite.
It's polite. Is there a mechanism in place for the optics to actually get firmware updates?
Okay, then. That's a good question because it depends sort of what your average lab equipment is. We didn't have any trouble opening them up, soldering some wires on, and doing the firmware updates. That probably isn't the operation you want to perform, how do you say, in real life?
In production.
Much less with devices that you don't necessarily have spares for. Okay, so there is a problem. I know at least 3 vendors. I mean, we only qualified 2, but we do talk to a larger number of them that are figuring out a way to let you. These are all I2 interface devices, so there are vendors working on ways that provide just enough internal life to let you potentially do a firmware upgrade over the I2 bus. That unfortunately also takes probably special software, which is not currently available other than that. So it's a bit of a problem right now. That's the truth, because you can send them back to the vendors who will, I assume under warranty, still replace their firmware, but your mileage may vary. You have to negotiate with your vendor on that one. But there are still more firmware updates coming. They're not done yet. Any other? Anybody else want to actually rip the Band-Aid off? All right, I think that's all I have to say. It's